In this video, we're going to talk about the applications of quadratic equations. You want to remember that a quadratic equation is in the form of y equals ax squared plus bx plus c. And remember, we can also replace the y with f of x. So one of the things that we can do when working with quadratic equations is we can pull out the vertex. The vertex is the maximum or minimum value of our quadratic equation. So if we were to graph one of them, graph it so that it opens downward, the very uppermost part would be the maximum. Conversely, if we had something that opened downward, the lowest part would be the minimum. So when you are working with a vertex, you're going to look for words that have the extremes, the biggest, the smallest, the largest, the greatest, etc. The vertex formula, you want to remember, is an actual point. And the first part is the minus b over 2a. So you write your the equation you're given in standard form, ax squared plus bx plus c, and you pick out the a and the b along with any signs. You plug it into the minus b over 2a. That'll give you the x component, and then you plug that back into the equation, and that will give you the y component. The x value is where we know what y equals, and we are curious to find what the x is. Now we're using x and y, but depending on the problem, we might use t for time that'll correspond to x, and h for y that corresponds to the y value, the height. So we had talked about this in previous lectures using the square root property, the zero product property, or the quadratic formula. When I do these, yes, it's nice to be able to see if you can factor them, but if you can't factor them, don't spend a lot of time with it. So the first slide is going to actually incorporate all three different things that we can do with a quadratic equation. So when a rocket is shot into the air, its height h in feet above the ground is a function of time in seconds. The height of the rocket can be found using the formula h of t equals 208t minus 16t squared. And we want to find different parts. So the first thing we want to do is how high will the rocket be at 8 seconds? So we know that we have an x and a y. The x is time, and the y is the height. A quick way of determining that is whatever variable is squared, that'll be the x value. So here we have t squared, so that corresponds to the x component of our function or formula. So to find the height at 8 seconds, we're just going to simply do h of 8. And we will plug in our values, being somewhat neat about it, if we can, being very careful with any negatives if we're given those. And if we plug these into your calculator, you should get 640 feet. Now we don't know what side of the graph that's going to be on. We just know that after 8 seconds, the rocket is 640 feet above the ground. So if we were to sort of do a graph, and we know after 8 seconds it's going to be 640 feet. We don't know if it's on the left side or the right side of the graph. The second question asked us what was the time it took to reach 672 feet. So I'm just going to rewrite the equation, minus 16 t squared plus 208 t equals the 672 feet. And to solve this, we're going to move the 672 to the other side of the equal sign. So we'll have minus 16 t squared plus 208 t minus 672, and that'll equal 0. At this point, we can either use the quadratic formula or we can factor. One thing I like to do, whether I'm going to use either the quadratic formula or attempt to factor, is to see if I can get rid of any greatest common factor. Unfortunately, we can actually factor out a 16. So that'll give us, or excuse me, minus 16. That'll give us a t squared minus, because we're dividing that, and that'll give us a minus 13t plus, because again we're dividing by negative 16, and that'll give us a 42 equals 0. Now this one was planned just right so that we could actually use and factor it, but if you can't factor it, or even though you may pull out a greatest common factor, what remains may still not be factorable. So at this point, what is inside the parentheses is what we need to solve. Now at this point we could factor it, or we could put it into the quadratic formula, but fortunately we can actually factor this. So that'll give us t minus 6 times t minus 7 equals 0. You'll notice that I'm bringing down that minus 16. It still plays a part. It actually has no bearing in this part, but we don't want to actually lose it. I'm going to move this up a little bit. So minus 16 equals 0. We know we just throw that one out. The t minus 6 equals 0, and the t minus 7 equals 0. So to reach 672 feet, it'll take 6 seconds or 7 seconds. And so we put 6 here and 7 here. This is not going to be anywhere in this scale. We can bring back the 8. We know that in 6 seconds or 8 seconds, the rocket reaches 672 feet. So if we just sort of, it may not look the best, we'll just pretend they're all lined up. You can see that the 8 seconds has to be on the other side of the 7 seconds. Now to fully confirm this, we want to find the maximum height. Now when we're using the maximum height, I want you to remember that when I use maximum, I want you to think vertex. If I use minimum, I want you to think vertex. So we know that t, which is time, equals minus b over 2a, and then the height we will just plug back into the function, because we do want to know the maximum height. So the t part, which is the x part of our point, is the time. So we know that b is 208, so it'll keep that negative. We don't want to lose any of those signs. All over 2 divided by minus, oops, little mistake there, minus 16. I'm doing the multiplication in my head. And if we do this division, we get 6.5. And since we know we're dealing with time, we put the units. This does not mean that the maximum height is 6.5 feet. It takes 6.5 seconds to reach its maximum height. So now if we do h of 6.5, plug it back in the equation, we get 676 feet, which Again, don't worry too much about how I drew my graph. This is just giving me a general idea. So it looks like our graph, though not quite to scale, shows the various components. So this is a good problem to feel comfortable with. It gives you the ability to look for plugging in a value for x, or in this instance t. The middle one gives us, we plug a value in for h of t, or h. And the third one lets us use the vertex. Now the middle problem, we were able to factor it, but if we weren't able to factor it, or if you didn't see the factor here in the third line here, the t squared minus 13t plus 42, there's no harm in taking this and using the quadratic formula. So that's the first example. I'm going to end this video, and then there'll be a couple more another video or two for more problems. So this is just an overview.